Okay, so let me walk you through the region we're looking at here in case you're not from Colorado. This is the Colorado Front Range. It's the city of Denver. Down here, you may know where Boulder is. And what's remarkable is that there's been a development of a high number of oil and gas operations in this area, which is to the northeast of Denver and east of Boulder. I think they're on the order of 25,000 wells in this region right now. And this has been a focus of research for several years, with a number of very nice papers have come out in the last few years. And most of these have been centered around this site here, which is the Boulder Atmospheric Observatory, which is a NOAA-maintained research facility. So the work so far mostly is from that side. And the primary findings have been reported in these papers that there are quite enhanced levels of non-methane hydrocarbons seen in the atmosphere. This a comparison of levels seen at BAO with other urban areas which show highly enhanced methane levels. These VOCs are correlated quite closely with methane, and there seems to be a directional dependence, as shown in the Sparthout paper, where air transported in from the east and the north, again here's BAO, has higher levels than air transport from other regions. This was also seen in the Petrone et al. Paper, and which in addition to that also showed some seasonal differences. And Jessica Gilman's paper then took that a step further and derived OH reactivities from the observed VOC composition. And they concluded that a very significant amount of the OH reactivity is driven by oil and gas related emissions, which suggested that the VOC released in that region should play a major role in ozone production as well. So those are the things we looked at a little bit more. We moved away from the one Boulder Atmospheric Observatory a little bit further out, including residential areas. What's unique about this region is that oil and gas operations have moved very, very close to urban developments. This is a picture from Erie, which is right around the corner from the Boulder Atmospheric Observatory. Also this region, and this was just mentioned in the previous talk, has been a violation of the ozone air quality standard. This is the records, more than 10 years, from 6 different sites in the Front Range, and you can see that the regulatory value taken exceeds the 75 ppb threshold very consistently year after year at most of these stations. So as I said, we've gone out a little bit further, and I'm only going to present some highlights here right now because we have 3 more posters this afternoon that show this work. There's also been a recent publication that you can look at. So we've gone from Boulder further out to the north and south, outside of the city. Then this is where the Boulder Atmospheric Observatory is. I will show you some data from Longmont. And then going further out, deeper into the oil and gas field, comparing some data from Platteville and Greeley. A number of these measurements are based on a new or somewhat modified method where we've taken integrated samples over 3-day sampling time. So these data I'll be showing you reflect averages of levels seen over 3 days. And then I'm going to touch this just a little bit, showing at what we found on the dependency of ozone levels on transport in the region. So starting up here, these are levels for 3 alkane hydrocarbons, ethane, propane, and butane. And this is in the right vicinity of the Boulder Atmospheric Observatory, going from the west towards the east, northeast. So this is West Erie, East Erie, and Longmont. You can see there's a tendency of higher levels seen moving from the west to the east. This takes this a little bit further in scale. This compares levels for ethane, butane, and propane, I think, using background levels. Then this site here is in the city of Boulder, right at one of the busiest intersections in town, and moving from here eastwards toward Lafayette, Erie, and then Longmont. And you can see very nicely there's a steady increase in all of these compounds, ethane, butane, and even one of the alkenes we looked at here. This opens this up to an even wider scale. We included here data from the Colorado Department of Public Health. This includes in the green color data from Platteville. So now we are in the center of the basin, and you can see that the previous work and these observations here from Erie, I think these are the blue colors, compare such that there's even significantly lower than values seen moving into the center of the basin. And again, these also compared with Los Angeles being at the very low end. This is a nice analysis where we look at the relative distribution of VOC species to the compound mix, and you can see as you move from Denver to Longmont into further into the region that the relative fraction of alkyne hydrocarbons, alkanes, increases steadily to where it becomes the by far overwhelming contribution of the VOCs that are observed. This is an attempt to look at changes with time, which is very challenging to do since there are very few records to compare more recent data with historical data, but we found a few data sets. This is comparing the change from 91 to 2007, trying to align the data as well as we could, and we see increases in all of these hydrocarbons over this span of time. Similar to looking at a more recent time frame. And then this is an analysis done by Chelsea Thompson that I really like. It utilizes a wider set of data, and it compares the I-pentane over N-pentane ratio, where high values in this ratio are characteristic for urban areas and automobile emissions, and the low end we're seeing a fraction that's more characteristic for oil and gas emissions and ambient levels seen in oil and gas regions. And what we see here for Boulder, comparing two studies, that over this time frame of some 20 years, the ratio of the pentanes has shifted significantly from a higher value to a lower value, indicating that within Boulder, the influence of oil and gas emissions on the pentane hydrocarbons has likely increased over that time period. This looks at VOC over methane and VOC over VOC relationships. So let's look at the upper left set of data first. And again, these are these integrated samples comparing Boulder data in red. And you see consistently looking at ethane, propane, and butane that for within the city of Boulder, both of these species are relatively low and don't show much correlation. But as we move down this list, moving closer into the oil and gas region, both of these species go up and the correlation increases with the highest levels seen on the eastern Boulder County line. This looks at levels of benzene and benzene relationship with propane and oil and gas tracer compared to the relationship between benzene and acetylene, which is a tracer for combustion and in this urban region mostly transportation, automobile emissions. And what this analysis shows, comparing Denver with Platteville data, is that in Denver the benzene is tightly linked to acetylene, inferring that a lot of the benzene is tied to transportation, whereas in Platteville this relationship is reversed, where a lot of the benzene is tied to emissions to propane used as the oil and gas tracer. Also, please note that the scales of these graphs are different, so overall levels of benzene are quite higher in Platteville than in Denver, and we compare this here with the health threshold suggested by the WMO, and you can see that at both sides, but even more so at Platteville, a lot of the data points exceed this benzene health threshold. So now I want to touch the influence on ozone And this analysis we did using two sets of data, one from the Boulder Atmospheric Observatory, the other one from South Boulder, and this map shows the population density. And what's important to note is that most of the population in this region is to the south, southeast, to southwest of these two sites. But most of the oil and gas development, these red dots, are to the north and to the northeast of the site. And so there's a lot of graphs and a lot of dependencies. So we did this wind rose analysis where we used wind data from the sites and tied it up or paired it up with ozone observations to generate these wind roses. But what you can already see here is that for both of the sites in the summer, there's a clear sign that the highest ozone, these colors here, are seen in transport from the east sectors. I'm going to show this in a little bit more detail. This looks down here at the number of exceedences of the 1 hour 75 ppb level as a function of transport from these sectors. The sectors are shown here in this color pie, and you can see that for BAO, the predominant source upwind direction for elevated ozone are the north to east sectors, which for this site correspond to the oil and gas region. Very similar for the South Boulder side. You can see how predominant the high ozone transport from this region is, whereas transport from the city of Denver causes a much lower number of exceedences. Now, if you normalize each sector to its own and look at the distribution, you see something very similar that for both of the sites, but clearer so at South Boulder, that air transported from these sectors show much higher, almost 10 ppb higher distribution in ozone than air that's transported from the urban region. Combining these data sets, we concluded that 63% of the 1 hour ozone above 75 ppb is transported from oil and natural gas areas, while only 9% is transported from the Denver metro area. This actually is a nice agreement with a study that we found that was done a number of years ago, and that had a different approach using data from 4 different sites, Fort Collins, Rocky Mountain National Park, Rocky Flats, and Chatfield, and it used trajectory analysis to analyze high ozone events. And that study is published in the CDPHE report, and it similarly found that the oil and gas region has a very strong, a very clear signal of being a transport region for the high ozone events in the region. Okay, so let me summarize this. The key findings are there's very good agreement now between 5 studies that show elevated VOCs at BAO, Erie. We don't see these levels just at the site, but also they're persistent throughout the region. The VOCs increase going from that research facility further into the basin. These levels that were seen in these previous studies persist throughout the year. We see this through the summer into the winter. The potential for ozone production that was suggested in the Gilman and Swarthout studies is confirmed by the studies that we did and that we found that the state did a while back that investigate the ozone climatology. And from that, I think we're pretty close to concluding that the oil and gas emissions do have a significant impact on the summertime ozone production and the exceedences of the ozone standard in the region. Thank you.
We have time for a couple questions.
Steve?
The latter part of that talk referred to transport, and I'm wondering, I guess I have 2 questions about that. One is, when you say transport, do you just mean analysis relative to what the local wind at a given site? And second, how do you differentiate between transport of, say, Denver urban emissions out the South Platte River Valley, and then retransport of those emissions back during upslope flow relative to direct ozone production even in oil and natural gas emissions?
Yeah, you bring up a very good point. The topography and the flow patterns we see here are very complex and interesting in that we see a day, nighttime, upslope, downslope flow, where at night air from the region is pushed towards the east, and then during the day it's kind of sucked back towards the mountains. And we've discussed this and brainstormed about that exact question quite a bit. We think that looking at the hydrocarbon signatures that you and others have seen at BAO, that we've seen all through the regions, it's dominated strongly by oil and gas alkane signatures, and we don't see a very clear change in the ratios during upslope and downslope. So the idea that Denver emissions drain into the Platte River Basin and then get transported back the next day, I think is possibly valid, but I don't think it's a strong influence given the hydrocarbon signatures that we observe day and night in the air that we have seen in this region. The other question was on the transport and the wind direction data. So we've compared wind directional data with some high-split modeling, and we've gone the route to use for this case the wind direction data, also to contrast it with the earlier NOAA study, and for having data that's much higher resolved temporally and that's co-located with the sites. That's what we used, and we think we've got some very interesting information out of that, but I'd like to invite anybody to try to reproduce this with high-resolution transport modeling as well.